Thank you everybody for joining. This is another Scanner Spotlight series webinar by Digitized Designs. I'm Patrick Paz, Director of Engineering with Digitized Designs. And today we're going to be looking at the Scantech NimbleTrack. I've got it 3 parts today because we'll be using it with the track probe. We've got the tracker, scanner, the probe. I've got an example part and a turntable to use with it. I'll kind of just cover a little bit of everything, what the scanner is really good at, what it does, kind of the way it changed the game when it came out. And I like to keep it really casual. If anybody has any questions, feel free to drop them in the Q&A. I'll try to keep an eye on that as we're going. If I miss anything while we're going, there will definitely be dedicated time towards the end to answer any questions you might have. If there's anything in particular you want to see, I've got a whole bunch of parts nearby I can grab. If you've got an application you're curious if this would work for you, feel free to let me know. I'd be happy to drop it in and fit it into the agenda. Before I share my screen and get started with all the software stuff, I'll just talk a little bit about how the hardware and how it works. So like I mentioned, we've got 3 pieces. Sometimes you're just using this with 2, the tracker and the scanner. As you can see, they're both fully wireless. They work on Wi-Fi, so they're connected through a little Wi-Fi router to local network. That's how they're connected to my computer right now. You have the option of wiring them up as well. In that case, it's a little bit more cumbersome to use them with the wires. You don't get the freedom of them being wireless. They can be faster, or they are faster at scanning in that configuration. But fundamentally, these are a blue laser 3D scanning system, metrology grade accuracy, accurate to 20 microns, about a little bit better than a thousandth of an inch. In local accuracy, so small features, anything smaller than a few feet, and then across the entire volume of this tracker, which I'll explain what that means in just a moment, accurate volumetric accuracy, 49 microns, a little bit better than 2/1000 of an inch. So the way this works is you've got this tracker, it's this guy on this tripod, it's got these 2 cameras surrounded by those LED rings. These do a few different jobs, but always one is tracking the targets on the scanner. If you've seen other handheld scanners that are just one device that work with targets, often you'll see the targets have to be on the part, like you can see the targets on board this turntable here. Then in that case, the cameras on the scanner have to see targets for those to be able to work. In this case, all this has to do is be able to see the target on board the scanner here. It knows where this is in space. And then these 2 cameras and these laser emitters on the front will scan the object in front of the scanner. They'll project a laser grid or a grid of lasers onto the object based on how those lasers bend and deform. These 2 cameras pick that up and register all those deformations as 3D data, very accurate 3D data relative to the scanner, which is placed accurately in 3D space by the tracker. So in short, as long as the tracker can see the scanner, this will scan whatever you've got it pointed at. All those points will stream over into the software as a point cloud, which you can then mesh, create a surface model of whatever you might be scanning that's accurate to those accuracies I specified earlier, 20 micron or 49 micron through the whole tracker volume. Back to that tracker volume, that is a truncated pyramid shape in front of this tracker that is the volume that it can track very accurately. Starts about 2.5, 3 feet in front of the tracker and goes out to 10 feet, so about 3.5 meters out in front of it. Starts off as a smaller square and it gets larger the further away you go from the tracker. Once I share my screen, we'll pull up TViewer, the scanning software, and we can kind of visualize that. It'll show you where you've got the scanner in that volume to make sure you know you have the tracker positioned somewhere that you can use it for scanning whatever you have it pointed at. That said, let me share my screen here real quick. So you're seeing a CAD model of, not yet. Now you're seeing a CAD model of this part I have here pulled up in Polyworks, which is where we're going to be running TViewer from. You can run it on its own. We're going to run it today as a plugin inside of Polyworks. That looks like this little guy when you're probing, and we'll open it up to do some scanning with as well. Before I jump too much into that, I'll also forgot to introduce the 3rd piece of hardware here. Optional accessory for the NimbleTrack is the track probe. So instead of scanning, this guy has targets on it, and it has a probe tip just like you see on a CMM or like a portable CMM arm, like a ferro arm, for example, and then a couple of buttons on the back and a trigger button. And this guy works, you can use it with just the tracker by itself, you can use it with both of them together, but as long as the tracker can see this, you can probe to similar with all the same accuracies specified for the scanner. So I can probe an alignment, for example, probe some features that might be a little harder to scan, things that are a little bit deeper. This doesn't have an extension on it right now, but I've got a kit where you can, it comes with the kit, you can put up to, by default, 100mm extension is what comes with it, but you can put anything you can punch into the software, have longer extensions and reach deeper down into holes and things like that. You don't have to see all these targets on board here while you're scanning. You can cover up to half of them, depending on what configuration you have it in. So you could, stick it deep inside of here. I'd point it this way if I was using it with this tracker, and as long as it's visible to the scanner, to the tracker, you'd be able to probe with it. Cool. So just starting off with, let's get the bigger T viewer window opened up, and I'll show you that field of view. So again, this is running from inside of Polyworks. Sometimes I like to make it a little window inside of here, but we'll make it full screen so you can see everything a little easier. So all my devices are hooked up. First thing we'll do is just visualize this tracker's field of view. So that's what this little truncated pyramid showing me here, and you can see the tracker orb right there is representing where the scanner is in that tracker's field of view. If I pick it up and move it, it moves accordingly in the tracker's field of view. If I get it closer to it, you can see right there where it disappears is where this tracker's field of view starts. And then I can move it all the way out here. Move this around so I can kind of show you the size of it a little better. This might be off camera here, but that's about where this starts. And I can go all the way over to the wall over here, as long as it stays visible. I blocked it with my body for a second there, is why it kind of flickered out. And pretty much over to the wall here. So the full width of this room, I'm able to have this. And notice I can go a little bit higher and lower out here where that field of view got bigger. As you get closer to the tracker, that square is smaller. Further away, it's a little bit larger. So the simplest way of scanning with it is, if you're working on a part that can fit in the whole volume, you just park the tracker somewhere that's pointed at it and use this mode to make sure that, like for this part, for example, I can make sure that I'm everywhere, that I can reach everywhere that I need to be able to scan this guy. For example, if this guy was tilted, the tracker was tilted too far that way, it's not showing up on the screen right here. It is over here, but I lose it right about there. That means I just need to come over here and turn this a little bit closer to me. And it shows up. You can see the little red dots in the top right hand screen. There's like a top view and a side view, 2D representations of this same information there. So again, if you want to scan something that fits in the volume, you just point it at it, make sure you have enough room, and scan away. If you have something larger, you don't have to scan something you're not limited to this field of view. You can chain them together using these targets. So you've got adhesive targets that come on a little plastic sheet that you can stick onto two things. You've also got these target pucks, are an optional accessory that you can get. You can acquire these targets using the tracker and then use those as reference points to, in this case, either turn the turntable in front of the tracker, it'll keep up with all that position, or you can move the tracker around this, versus otherwise, what we were talking about the first time, the tracker has to stay still for everything to work. If you scan a little bit and you move the tracker and you scan a little more, you'll see double show up on the screen. The tracker thinks it's all in its original coordinate system and you've moved it, so it'll show up. But again, with targets, you can compensate for that in a couple of different ways. So we'll do a quick, just to kind of show you what I mean. I'll show you exactly what I was talking about. We'll start a new scan real quick. And as soon as that starts up, we see lasers show up on the part. You see lasers show up on the screen, and then laser data getting collected over there are all on the screen. So those dark blue, I'll hold it still for just a second so you can kind of see what I'm seeing. Sorry, I didn't quite tilt myself back close enough to where we were. Let me start over real quick. Sometimes I find this is a great way to teach how the Nimble works, is like make mistakes on purpose and then you see what happens. There we go. So I had the tracker pointed a little too far that way. It wasn't quite seeing the orb where I'm standing right here. So now I just tilted it back forward a little bit. So I'll hold still for a second so you can see what's going on. All those dark blue lines are where the lasers are hitting the part right now and where the scanner is able to pick them up. I'm holding them still just so you can see them. That's that big laser cross pattern. All that other light blue data, now that I move around and paint a little more, that's data that we've already collected, and that there are thousands and thousands of little points scattered along the surface of the object that the scanner is able to recognize. And as I move around, I'm basically painting the surface of this object with those points. And this whole process is super visual. If you see stuff show up on the screen, you know you've captured it. So I get a lot of questions about how do you know when you're done? Basically, if you can see everything you want to have scanned on the screen, it is done. If you see like the stuff on the inside there, it's kind of a little like hatched. It's not filled in all the way. That just means I need to go scan over it one more time, maybe get a little closer, hit it from a little different angle, and it'll fill in. Every area has to get hit a couple of different times, but these scanners, these lasers collect data so fast, unless you move really fast across the object, you're going to hit each of them's area is going to get hit by many lasers and get like saturated with data before you go any further and fill up. So just to kind of illustrate that example I was talking about earlier, here's a scan from just one position, assuming the part and the turntable, or sorry, the part and the tracker stay still. Showed it to us from behind. There's that area that we scanned from. We run a quick disconnected components filter to try to just get rid of some of that extra noise it's inherent in laser scanning and really easy to take care of. And so now if I move the tracker a little bit, we'll move it a little more towards me by just a couple degrees. And we'll scan again in the same scan. So I'll see a second one of these parts show up on the screen. You kind of see I like to call it like seeing double. I moved the tracker and didn't tell the software that I was doing that. So it thinks the coordinate system's the same. So it thinks the part moved because it thinks it stayed still. But it's really easy to add targets in and allow that movement to happen. Let you scan everything all from one position, or move the tracker around, or have the part move around while you're scanning around. So let's see, actually we'll keep that. Let me add a new scan here. This time we're going to start by collecting the targets with the tracker. So I'm just going to keep the tracker pointed in the same direction. Set the scanner off to the side. Before I move it around, I'll zoom in. So we're seeing the same tracker volume that you saw before, but now it's showing those targets pop up in space as well. If I move the tracker around, you can see those show up. And if I spin the turntable, you see those targets move accordingly. The red ones are the ones it sees right now, and the white ones are ones like it knows exist, but it's not using right this minute. So as I complete a full revolution of this table, it's going to pick up most of the ones on here. It's not going to get the ones on top of these pucks. I have to get the tracker a little bit higher for that to happen, but the ones on the side are more than enough to do what I want it to do. So we'll end that. We'll enter in this mode called dynamic tracking, which now, in addition to the scanner having to stay visible to the tracker, we also have to keep a few of these targets in view as well. But as a result, I can scan like you just saw me doing, leaving everything still, but now I can turn this turntable and the tracker's compensating for that movement. And now I can keep this tracker or keep the scanner in one position like this and scan a little bit quicker, a little more flexibly. And again, this is would allow me to move the tracker around as well. So this is how you'd handle larger stuff. If you want to scan a full vehicle, that doesn't quite fit in the NimbleTrack's field of view, but you could throw a handful of targets on 3 or 4 sides of that vehicle, acquire them first, the way you saw me do with this turntable. In that case, you would pick up the tracker and move it around instead of just turning the turntable around, unless you have a car-sized turntable. Then do the same thing here. Instead of turning the car around again, though, that would be put the tracker in one position, kind of scan as much as you can from there, and then when you need to move the tracker, all you have to do is pick it up and move it, and then the targets will let it automatically account for that movement. It's also let somebody move it as well too. We've had a couple situations when we needed to scan something very quickly, like for example on an assembly line when you're you're in the way of production, production's halted, and you need to go out there and measure something very quickly. Sometimes it makes sense to take two people out there. One person can kind of man the tracker and move it for you as they see that you get into positions where you're not, not being able to scan anymore. Move the tracker for you and really flexibly let you get scan very thoroughly. So we scanned pretty much everything we can capture from this side of this part. If we wanted to flip this over and scan it from another side, we can definitely do that and combine those two together. I haven't checked on the Q&A in just a second. Let me make sure nobody's waiting on me. Cool. Let's see. Let's grab a new, start a new scan. We'll do exactly what I was just talking about. Flip this over, kind of repeat the process we just saw. Do this one a little bit quicker so you can get a feel for, if you were scanning parts like this all day long, how quick that might go. NimbleTrack is along in the middle of the range of like the current generation of Scantech scanners. There's smaller ones like the SimScan, meant for smaller objects, also capable of doing larger stuff, but those are just the handheld scanner on its own, so you do use targets with that. The biggest jump from that to the Nimble, convenience-wise, is that you can get rid of the targets, do larger stuff a little bit easier. You've also got the like big brother of these, the TrackScan Sharp S, very similar systems. The orb's a little bigger, the tracker's a little bigger. They can see a lot farther. So if you're doing really large stuff all day, those are a little bit better suited. But this one's really nicely positioned in the middle. It's an excellent value for the price. It's super, honestly, probably the most flexible for different size applications. You can do small parts, anything you could fit on this table. I could go even smaller. We can increase the resolution a lot. We're at a pretty moderate resolution right now, so we're not capturing the finest details since we're on a little bit bigger of a part. But you can do tiny parts all day long with the Nimble. You can do vehicles with no problem. So it's super flexible when it comes to size and resolution. The wireless capability is really helpful with that. If you've ever like fought with cables when you're trying to scan something like this with like an older generation scanner, you might know what I mean there. The scanner here has specifically the scanner orb, just this part, not the whole NimbleTrack system, has a really interesting feature with the scanner where you can use it standalone, just like you would the SimScan, like I mentioned. You notice the little end here it's very similar in camera and lasers configurations to a SimScan. I'll make sure I show that before this is over, because that's something that there's definitely similar like tracker style systems on the market. That's something really unique to Scantech, to be able to use that on its own. So there's our second scan. We'll do another disconnected components and filter out some of that noise. And then aligning these together just looks like picking the one I want to stay put, the one I want to align to it, the other one that's flipped over. On this guy, I'm also going to delete out the table real quick. Chopping out a little bit of the part, that's okay, because I know I've got that in my other scan. And then we'll run an alignment. So this is going to show me one of these scans up in the top left. Change my center of rotation. And the other one down the bottom left, my job is to pick 3 common points between the two. So the very first thing I like to do is just line them up to where they're facing about the same direction. And then zoom in a little bit closer, pick a point, pick a matching point, and then scroll around and do the same thing in a couple other places. These don't have to be super close by any means. They just have to be close enough to get the computer started. So I place these three. Before I place that last one right here, I'm going to point you over to this side of the screen. So this is how these two scans are currently aligned. When I place this third point, you see them snap together most of the way. They're still not aligned perfectly, but that's because I'm a human and I place those points. The computer will take over and kind of wiggle these around until it minimizes the error between them, and they look much better aligned. At that point, I can fuse them together into one point cloud. So now I have this new project, new Scantech, or sorry, scan viewer. The scanning software likes to call them projects. And I have everything we captured from both sides, including the floor on one of them that I forgot to delete, all in one. That's really easy to fix. We can just grab this one that I forgot to delete that from, and now we already did the alignment step. So I just need to snip the floor out of there with a quick lasso. Almost. I was a little bit too careful trying to save the part though. Again, that's the part where I know I got that really well in the other one, so I can be a little bit more egregious and delete a little more. Again, those two now are aligned, so I don't have to go through that alignment again. I can just merge them together like so. Now we have both of those put together. If we zoom in really close, this is still point cloud. If you zoom in, you can see the individual squares that represent those points. We can mesh that, connect all the dots between those points, make an STL, and make a true surface instead of discrete individual points. If we zoom in really close to a point cloud, you're never actually going to see any true surfaces. They're all individual spots. In this case, they're just represented as squares, but an STL really will. You zoom in a lot, you see that's an actual surface model. So spin it around a little bit. I can show you those triangles just to help you visualize if you've not seen a polygonal mesh before. That's what I mean here is all those individual points got connected into triangles, and now those triangles wrap this full surface, and that describes the geometry a little bit more efficiently than a point cloud does. If I zoom out there, it's just taken over the whole screen because those triangles are so small. We scan this at a resolution of 1 millimeter. You can go all the way down to 0.02 millimeters with the Scantech software. 0.1 is a pretty coarse resolution, so you can get a lot finer detail on stuff. It's like you can see there's some numbers there since we're at a little bit coarser resolution. Those kind of get blurred out, but I'll show you what that looks like if we crank that up just a little bit. So we went from 0.1 to, 1.0 to 0.25. And what that is how close together it's placing these points that it captures. So they're about 1 millimeter apart before, now they're 1/4 of that distance apart, meaning in the same area, there's actually 16 times that number of points there. So we zoom in, you can see those numbers are resolved a little bit more clearly now. There's even some other engraving up here that's probably, it'll definitely show up in this, but this is still could use a little bit higher resolution. I'll show you another cool feature of the scanning software. So oftentimes you'll want a part like this, there's only like this little number here and the one over there, you'd want at max resolution. You'd want to get everything else a little lower. As you can see, I'm having to move a little bit slower just because there's so much more data to collect to fill in the same amount of area. Oh, I'm moving the turntable and I'm not in dynamic tracking. That's why that's ugly. Sometimes I talk a lot and then I just do stuff. There we go. So yeah, another one of those examples of if you're not in dynamic tracking, don't turn the turntable. Show that one more time. Also, we've been in this laser crosses mode this whole time. Let's switch to One of the other ones, I've got two other modes, three total. This one's parallel lasers. It's better suited for higher resolution scanning like this. It's a little smaller and asks you to get a little closer, but it is exactly for stuff like this when you're trying to scan harder surfaces or really fine details on stuff. You've also got single laser mode, which I'll show you in just a second. This one's really good at getting deeper inside of crevices if you're deep into corners or holes, but it is not quite as speedy as the other two because it's just that one laser. It's usually used at the end of a scan to try to fill in like the last couple of spots that you might want to capture that didn't come in with one of the other two modes. But usually, again, those are probably like they're deep into holes and crevices and things like that. Let's look at what we've got so far here, and I'll show you something called fine scan. If you want to up the resolution in a smaller area of your object, you can isolate it on the screen and increase it separately from everything else. Disconnect the components and get rid of some of this noise. Cool. Yeah, there's those numbers at that higher resolution. Over here was what I was talking about. These are really even finer details than that. They definitely showed up, but they're still, they could be a little bit better. Fine scan, let's do half of them, for example. And then I can do a couple of different things. I'm going to just do a low fine scan. It's just going to double the resolution in that area. But you can double, quadruple, or multiply by 8 that resolution. And you'll see what happens in a second when I scan back over that, it's going to delete all the data in that area and let me fill it back in with this higher resolution data. Zoom back in and see what that looks like. Yeah, you can kind of see there. So there's the difference between just 0.25 and 0.125 millimeter resolution. And again, we can go up to 0.02 with this scanner specifically. I've got an open question about can you use the scanner without the tracker? And yes, I think I mentioned earlier, but that's great segue. We'll show that now. Start a new scan. Let me switch out to a different part. One that has a few more targets on it for showing this. See, this has a handful of these 6 millimeter diameter targets on it. So when you're using the scanner without the tracker, it doesn't, without the tracker, the ordinary way of it telling it where it is in space, you'll use the two cameras on the scanner will need to see targets to be able to keep up with where it is in space. So let me turn this guy away. It's super clear it's not getting used. We'll just set this to only scanner mode. Let's do 0.75 millimeter resolution. And we'll start out with just acquiring targets, and this time with the scanner instead of the tracker. One more adjustment. I don't have it set to, there we go. We're only using 12 millimeter markers. Now we're going to use both those and 6. Now you'll see these LED rings on the scanner light up, and we're able to acquire targets with just this on its own. If you've seen a handheld scanner like a SimScan or K-Scan Magic, this is a little bit more like how those, well, exactly how those work. So I've acquired those targets. We have this, I like to call this like a target skeleton. You can kind of see the outline of the turntable and the object. Start laser scanning. Now we're scanning with just the scanner on its own. This is everything you saw it do before. When you use the tracker with it, you get that flexibility for large areas. But if you just need to do a small part on a turntable, like this one's a little big for a turntable, is why I've got some targets on board. But if you've got something smaller than about a couple of feet, you can set that on the table and just use the targets on board the table here. You wouldn't need to throw any targets on the part at all. You just have to get the scanner out and not the scanner and the tracker together. Way this is really neat is if you're, I've seen it a lot with like car scanning when you want to go deep into like the inside of car interiors and stuff. This outside of the car makes perfect sense to use the tracker all the time. It's super easy to just point it, have it pointed in the right direction, and then you can move the scanner anywhere you might need. But say you want to go like way up under the glove box in like passenger car, and you get the tracker oriented just right, you can definitely see most of the way in there. But if you get really deep up under into something in an engine bay or something like that, where it's not easy to see, have the tracker see the scanner, you could place a few of these 6mm targets. And as long as you can start picking them up somewhere that the tracker can see the scanner, then you can use them to bridge into somewhere like the inside of this. For example, we got all those targets inside of there. If this was like deep inside of a machine where it was just really hard for me to get to where the tracker could see this, this would let me bridge this really occluded area into the same, be in the same coordinate system as my original scan. So, all that data would be the whole outside of the car, everything you scanned with the tracker would be located the same. It'd just feel like you're adding to that scan somewhere that the tracker might not be able to see. It's gonna be really handy in real specific situations like that. Another question about how does the system work wirelessly? This person has seen other systems and they've been told that wireless doesn't transfer data well. Well, this whole time we've been using this wirelessly. I've got cables and a box. You can plug it up. We've done extensive testing with both ways. This was the first, I believe the first Scantech scanner we used or that came out that offered the wireless capability built into the scanners. There's been accessories that help do it, but naturally we thought the same thing. We want to make sure this is just as good of a scanner as we're used to, and that it's accurate. We've got certified ball bar standards. We test everything that comes into our office with. This all tests out within specification, whether wired or wireless. The only benefit you get wiring up is a little bit more speed. You can kind of see the speed I'm able to move across the object is still, I think, very quick with the NimbleTrack, but there's a noticeable speed increase. It actually doubles the speed with which you can scan when you wire things up. The other thing that helps with is the cables also provide power to the devices. When I'm wireless, I do have a battery in the handle of the scanner, and there's these two batteries on the back of the tracker. All of them are off the shelf. Like these are camera batteries. This is a flashlight battery. You can get these all, they're not proprietary. You can buy them online. So yeah, that's the other benefit wired gives you is speed and power. But batteries are easy to come by. They charge very quickly. If you get a handful, like four scanner batteries and 4 tracker batteries, and one of each charger, they charge fast enough to scan all day long with them. The scanner battery gives you about an hour, hour and a half. The tracker batteries, these are actually the long, slightly larger ones. These last 4 to 6 hours for both of them, and these are hot swappable. There's only one in the scanner, so you pop that one out, or power the scanner down, switch that out, power it back up. Takes about a minute to switch batteries. The tracker, it only uses one at a time, and it can use 2. So one dies, you switch that one out, and the tracker stays powered up the whole time. And those again last for several days. So one spare for that set of spares, 3 or 4 for this, and you've got enough to go as infinitely. They're charging faster than you can run them down. Let's see. Somebody else asked if the system's ISO certified for metrology, and the answer is yes. ISO 17025 for 3D scanner metrology certification is provided by Scantech. Yeah, let's see. So I think we talked about how to capture data, a couple of different ways of doing that. Once you have captured data, that's something you can do with it, especially when you're running it through Polyworks. Just send it over to the software. And save it off, and use it for inspection. So bringing it in, lining it up with the CAD data, and then you can automatically extract measurements or just surface deviation maps, so color maps that tell you how well the scan fits the CAD, and really quickly make inspections parts like this. Right now, this color map showing me exactly how far those scan is from the CAD. You can see that these numbers are not included in the CAD model, but they are in the scan. It might help visualize what this is doing. So you can see they're showing up as these red, the red side of green, that there's a little bit more material there. You're seeing the blue side of green shows there's less material. There's a little cutout here that's in the part itself, but not in the CAD model. So right now it's just such a big deviation, it's not showing up on the color scale. That's why it's gray, but it would show up as this like blue color if we were looking for deviations that large. Somebody asked where the system gets calibrated or serviced. So it does have a field calibration that you can do. There's two calibration artifacts in the case. There's a bar you use to calibrate the tracker, and a board that you use to calibrate the tracker and the scanner together. That you do that anywhere from once a day to a few times a week, depending on your use case. The device is calibrated at the factory before sent, and before it's being delivered. And if you need it recalibrated, you send it to Scantech's U.S. office in Irvine, California, where they recalibrate it and can recertify it. That's also where you'd send it back to get repaired if there's any kind of damage, if it gets dropped, or usually drops are pretty much the only reason they need to be serviced, but something happened to it. We do that. We've got a variety of warranty packages in that case, like premium warranty, where you get a loaner scanners included, so you're not missing the scanner while you're waiting on it to get repaired or recertified. It also includes recalibration once a year, some things like that. Talked about the scanner a bunch. Let me see. I'll show you what the probe, how that probe works here as well. And then unless anybody else had any questions or any sort of things they would want to see, I think we're about finished up. Let's see, switch that, make a new project. We'll bring back in that CAD model of this housing. Switch that part back out. Open up the probe and acquire some features. All right, so somebody just asked, I just noticed a similar question of can you probe in Polyworks? And yeah, that's exactly what we're about to do here. So this is when you run the TViewer as the Polyworks plugin or the probing plugin, you get this little interface here. It just shows you that everything's connected, including a probe. And then we can go probe a couple of features. So I'm going to say I want to make a plane, but we're going to probe it. I need to point my tracker back to the part. Now, as soon as I present the targets on the probe to the scanner, it will show up on the screen and we'll be able to probe with it. Bastards do a bunch of stuff at once. Good old turn it off and turn it back on again real quick. Please bear with me. Probe's battery powered too. It is not. It doesn't use nearly as much power as the tracker or the scanner because it's not a super active device. It's just got two AA batteries in the handle that are pretty much for the remote, like the trigger button that tells Polyworks when it's ready to acquire a point. Also, it takes regular probe tips, so they're just 4mm thread. You can order some from, like, we got our new ones from Metrology-Works when we need different sizes. It comes with a 6mm, 3mm, a scribe tip, and a handful of extensions with the kit when you get the track probe from Scantech. Here we go. So I've got my probe going. You can see the like live position of it. Since we're not in any kind of alignment, these numbers are just relative to the tracker. So that's kind of why we're way out in space here. And you see that Z is how far I am from the tracker, basically. So if I push towards the tracker, come back, that's what that's showing me. So we can go grab, switch to a plane from a point, and we can grab points on this plane here. Grab a couple of cylinders. With these three, there should be enough features to get us a real quick alignment. But yeah, again, that's why they're up in space. We're in the TrackScan's coordinate system. We can try to do a quick alignment of those three features. Okay, first, I've got to tell Polyworks where those are. The other way you can do this, you can scan and get an alignment that way. So especially with something that's not super symmetrical, you can scan and use that to make an alignment happen automatically sometimes, and then your probe will show up on the part exactly where it's supposed to be. Let's do these two slightly differently. I'll define them first because there's a bunch of them. I want to make sure I don't mix them up. Let's say the cylinder is going to be, what are these two? So creating those nominal cylinders, basically where they're supposed to be there. Now is the better way to go about doing it. I tell it where they're supposed to be first, and now I can go probe them. So I know this is this plane. Then I told it to do all three of those in turn, so it'll just should give me one of those cylinders. It's telling me which one. Now I can say, go probe that cylinder. And we will still, it's telling me those are all done probing. They're still going to be misaligned, but now I can use them to form an alignment. Say I want a best fit based on just those three features and pop those into place. So now if I go to probe something, say a comparison point, this will let me probe. Now I can put the probe somewhere and click off the trigger, and it'll tell me how far that point is from where it should be. Basically like a single little point on that heat map we saw earlier with the scan, for example. So I'm 18 microns off there. Oh, that one was, it thought I was on this plane up here. I was in this little divot. That's why we saw the that millimeter. I was also raised up off the surface there. That's why we're seeing off a millimeter there. Yeah, now that this is aligned too, if we go and grab the scanner and we're to scan right now, that scan data would drop in right into place. This is something we see is really popular with this configuration. A lot of the times alignment features are things like tooling balls or cone like probe seats, things that they're possible to scan, but it's really easy to just go pop, pop, pop and probe points in them. You know what those nominals are. You can have those entered into Polyworks, align them up, and yeah, get your alignment in 4 clicks and scan. Immediately have that scan drop into place and either measurements automatically extracted or a heat map automatically generated there. Especially helpful for parts that are really symmetrical that there's no other way to get them to align except for with those tooling balls. You can use the probe standalone on its own. With the tracker. You don't have to use the scanner, so I should say. You do have to have the tracker for the probe to work, but you can use just these two if you just need to probe some things really quick instead of scanning the whole thing. But one of the big benefits of scanning is you kind of see how fast and easy it is to acquire data. Instead of having to hit those individual features, you're getting everything you've pointed that scanner at. So if you scan, only measure a handful of features, later down the road you've done 10 different parts and you want to measure a different feature that happens to be in the scan data, which usually it is because scan data is so easy to just scan everything. You can enter that in and go create that measurement in Polyworks, send it back through time to all of those parts before, and extract that measurement from all those parts at the same time. Yeah, that's kind of the overview of the Nimble. We'll leave it open to any last questions anybody might have, but we're getting towards the end of our time here. And the last question we got was probing directly in Polyworks, and I hope that answered that question for you, that you definitely can. And you can probe independently too if you just need to measure a couple spheres. You don't have to, you can use TViewer on its own, grab those there, but we love Polyworks. It is very, very good at what it does. It's really great to be able to work with that directly. Cool, I don't think I'm seeing any other questions. So again, thank you for taking the time to join me today. We'll have about next month, we'll have another scanner spotlight. We've got, I think, 4 or 5 more in the queue and possibly more after that. If you would like to learn any more, you've seen something you think you might like and you'd want to see how it would work with your parts or with your company, please feel free to reach out to us. You can go to our website, digitizeddesigns.com. We have a contact form there. You fill out, somebody will get back to you. Info at digitizeddesigns.com. Will reach us. Got our phone number as well. Look us up, give us a call. We'd love to chat about how we can help with a 3D scanning solution. So everybody have a great day. Thank you.